So after probably 4 days or 5 days, we have been taking the class. However, so previously we have seen some mixing and everything has been seen. All these things have been seen. Today we'd like to concentrate on last and final concept of AES, that is how the key will be added to the each and every round. How this could be added to each and every round. Let us see this particular point here. So as we said, we do have 128 bit keys will be there for AES, and 192 keys will be there for AES, and then 232 bit key also be there here with AES. 128 bits will be taken, so 10 rounds of 10 rounds could be taken to mix the ciphertext, to mix the plain text and arrive ciphertext here. So we do have this particular information with us in the previous classes here. Okay, and the key schedules will be taken. Already we told that 128 bits, and this 128 bits will be applied. So 11 keys. It could be taken into consideration of 11 keys, because 128 bit key will be taken 10 rounds. So 10 plus 1, 11 keys could be taken into consideration for AES here. And then number of sub keys, of course, already have given here. So this thing will also be called as a new word, that is key whitening. This is called as a key whitening here. And how this could be done here in the sense, so for 128 bits length, we do have a number of rounds, it will be 10. So that we do have 11 subkeys will be there. First subkey or not subkey, otherwise subkey key not will not be taken into consideration. So key not will not be taken into consideration, and it could not be applicable for anywhere else. Okay, it could not be applied for anywhere else, and it is just use it to make the key. K naught will be always used to make the key, and it could not be used anywhere else in the AES. K1, K2, K3, and so on, K10 will be used here. Total number of things will be. So, and then these expansions will be, in DES also we have seen some kind of operations in terms of applying keys for each and every round. Thereby 64-bit key will be first forwarded to key parity dropper, then followed by parity dropper will be eliminates 8 bits, and it could be converted from 64 bits to 56 bits. And these 56 bits will be again divided into 2 equal halves, that is 28 to 28, and each 28 will be applied for left rounds. Okay, left shift operations. They do have some kind of stipulation for round number 1, round number 2, round number 9, and round number 16 does have 1 left shift, and remaining all will be taken 2 left shifts of the key here. Afterwards, they could be combined together, will be forms 48 bits, and they will be sent to round key here or there. But here we would like to consider this is not the situation in terms of AES here. In AES, total number of keys will be taken into consideration W0 to W43. So each and every W0 will be 8 bits long, and W1 will be again 8 bits long, and so on and so forth. W43 also 8 bits long here. Okay, for every round, 4 keys will be taken into consideration. Let me consider. So W0, W1, W2, W3. So these 3 will be applied for round 1, and W4 to W7 will be operated for round 2, and so on and so forth will be taken into consideration here. Okay, so each and every key bit pair will be 8 bits, and if you combine cumulatively 8 4s are 32 bits. All these things will be 32 bits. So otherwise So 4 words, sorry, yes, 4 words only, 4 words. These 4 words will be applied for so each and every round are there. Okay, and so all elements cannot, these things will be called as bytes here. So these 128 bits are going to be divided into, so 15 bytes. So sorry, 16 bytes, sorry, 0 to 15, that is 16 bytes. So each will be termed as K0 to, so K15. So K0 will be 8 bytes and, sorry, 8 bits, and K1 will be, so 8 bits, and so on and so forth. K15 will be, so 8 bits again. So initially W0 will be framed something like this. So W0 will be framed, so will be taken from, so something like this. K0 appended by K1 appended by K2 appended by K3 will be considered as so W0, and then W1 will be taken, so K4 and so on and so forth to K4 to, so K7 will be, so appended by, so you may be right, 32 bits will be written in a sequence of word, and that could be assigned to W1, and W3 will be taken into consideration. So sorry, K8 to, so K8, K9, K10, K11. So totally up to K11 it could be taken as W3, and W4 will be, sorry, it is W2, it is actually W2, and this is W3. W3 will be taken, so K12 to, so K15, K12 to K15, and these W0, W1, W2, W3 cannot be used anywhere else. This could not be sent as a key or sub key in any round. This W0, W1, W2, W3 will be used to, so generate round keys. These are used to generate round keys here. So right away from W4 onwards, W4 to 4 bits, 4 bytes will be considered as first round key, and W4, W5, W6, W7 will be considered as first round key. W8 to W12 will be second round key, and so on and so forth. Like that, we do have right away from W4 to, so W43. W4 to W43 will be considered as each and every round key. So that could be taken into consideration. Let us see how this could be framed here. So look at this. As I said just before, so K0 to K3 will be, so totally this is 8 plus 8 plus 8 plus 8, 32. 32 bits will be taken into consideration of one single W0 here. And so K4 to K7 will be W1, and round 0 cannot be happened in our AES here. Round 0 cannot be there actually. So it is used to prepare, so first key here, first sub key for first round here. So rounds will be always calculated right away from 1 to 10 here. Round not cannot be there in our AES here. Okay, and how this could be performed here in the sense, W0 will be exclusive ORed by G, and G will be taken from W3 onwards. Okay, so how this could be taken into consideration here in the sense, so W4 will be equal to, so W0 exclusive OR of G, so exclusive OR of W4. Sorry, W3. So this is W4. And W5 will be equal to, so W5 will be gets operated, W5 will be equal to, so however, if you take this particular output, this particular output will be completely, so transformed this one. So therefore W0 exclusive OR of, so what is that, W1 will be considered as a W5, and W6 will be equal to, so W6 will be gets equal to, so W1 exclusive OR of W1 exclusive OR of W2, and so on. W7 will be equal to W3 exclusive OR of W3, W2, of course, exclusive OR will be always commutative. So therefore, you could write anywhere else W3. So it could be considered as So these are the first round keys which could be taken into consideration. So here you need to understand, we know what is W0, W1, W2, W3 because already key is there with us. Key, so totally 128 bit key is there with us. So first 4 bytes will be W0, second 4 bytes will be W1. Everything is known to us because the key will be given before operating this AES here. So everything is known. But only one thing is not known here, how the things will be gets happened with this particular point, the G. G is not known us. So how this could be acquired? So this is the point here. So if you learn about this particular point, it is very easy to understand remaining everything here. Let me come across everything here. So look at this, how the G will be gets calculated here. Let us have a look here. First 4 words, so W0 to W3 are made up of from the actual cipher key in the sense K0 to K15, and it does have first 4 bytes will be taken as W0, and the second 4 bytes will be taken as W1, and so on, as I just before I have given to you. And then followed by rest of the words. So 4 to 43. 4 to 43 in the sense you could see, there it is. You could see W4 and W5, W6 and W7. How this could be gets prepared here in the sense, this is the way of preparation. WI, where I will be 4 to 43 will be prepared in such a way that I modulus of 4 not equal to 0. For example, so I will be 4 in the sense 4 modulus of 4 equal to 0. So that could not be taken into consideration. So I will be equal to 5 in the sense 5 modulus of 4 equal to 1. Yes, this condition will be get satisfied. So for those kind of issues, what we have to consider here in the sense, Wi minus 1, Wi minus 1, so exclusive of Wi minus 4. What does it means? So W5 will be taken into consideration. For example, W5 will be taken into consideration. Wi minus 1 in the sense I will be equal to 5 here. I minus 1 is that is W. So 5 will be equal to, so W4. So I minus 1 in the sense W4 exclusive R of, so I minus 4, 5 minus 4 equal to 1, W, so let me consider 1. So this is the specification where exactly you have to take it into consideration here. Where, so if this equality will be taken, I modulus of 4, for example, so W4, W8, W12 and so on, all these kinds of things, it could be calculated like this. If I modulus of 4 will be equal to 0, so we have to take one more extra variable here. How this variable, let me discuss in the next slide. So Wi equal to T exclusive of Wi minus 4. What is this T? Let us have a look here. For a while, you just wait for a while, it could be taken. So for all the condition which could be satisfied with this one, so with this one, simply speaking, Wi will be taken into consideration. W5 will be equal to W4 exclusive of W1. So W6, so 6 modulus of 4 not equal to 0, yes, it is also satisfied. W6 will be equal to, so W5 exclusive of 6 minus 1, that is, sorry, 6 minus 4, that is 2. So that is W2 here, W5 exclusive of W2 here, and so on and so forth. Except, so the 4 multiples must be taken, some other extra operation here. How this T will be gets calculated, this T will be equal to this value here, that is G. Let us have a look about this particular thing in the point of view of, so this G here. How G will be gets calculated here in the sense, this is the way of calculation of G here. So G will be, so each and every, consider as each and every sub key will be taken, W0, W1, W2, W3. Instead of W, we would like to consider as V0, V1, V2, V3. And these things will be gets mixed like this. These things will be gets mixed like this. So one bit, so right or left it is. Yes, it is right only. One bit, no, left, sorry. One bit left operation, 1 byte left operation is being done here, so that V0 will be transformed to, So fourth position, V1 will be first position, V2 will be second position, V3 will be third position. Okay. After that, each and every byte will be, this is 8, and this is also 8 here, this is also 8 here, and this is also 8 here. Each and every byte will be sent to S box. Already we have taken S box in the previous session here. So this S box will be taken, and then it could be framed by taking RC of I. I'll give you what is this particular RC of I after some other time. So just wait for one moment. I'll give you what is this RC of I. So it could be exclusive OR with RC of I. The first and foremost, V1 will be exclusive. V1 will be sent to S box, and output of S box will be, so again, exclusive OR with RC of I, and then everything will be combined together, will be forms in 32-bit. So it will be considered as the G value. Okay, let us see what are these values here. So the G performs 1 byte circular left. Yes, circular left shift in terms of word here, so that V0 to V3 will be get transformed. V1, V2, V3, and V0 would be transformed in such a way. And then followed by, after swapping, so this operation will be called as swapping. Shifting of 1 bit towards the left will be called as a swapping. After swapping, everything will be sent to S box. So after S box, so 1 and 2 will be exclusive OR. How this could be done here? Let us consider here RC of I. RC of I in the sense totally, so 128 bits will be, 128 bits will be there with you. 10 rounds can be taken into consideration. So first RC of NOT will be taken like this here. So 00001, this is the first value. S box, because the output of S box is 8 bytes, 8 bits. So these 8 bits will be exclusive OR with this particular value. If it is 081, if it is first one, so it could be X power 1, RC of 2. If it is first one, so it could be exclusive OR something like this. So by the next round, and the third round, fourth round, and so on and so on and so forth, up to 9 rounds will be 0 to 9 in the sense 10 rounds will be taken. So 10th one will be taken in such a way here. So consider this particular value, look at this as far as binary. So X power 9, so 9 in the sense it could be taken 0, 0, 1, 1. So this is 0. No, this is also 0 actually, this is also 0. So 1, 0, 0, 1. This is the actual value of 9 in terms of binary, right? In terms of binary, this is the value of 9. If you write something like this is 0 and this is 9, actually in terms of 9 here. But this could not be written in terms of 9, it could be written in terms of BCD form. In terms of BCD form. Okay, in terms of BCD form, 6 plus 3. 6 plus 3 will be equal to 9. Something like that, it could be taken into consideration. Why it could be taken into consideration here in the sense? So Galileo field, GF, Galileo field of 2 power 8 format. Galileo field 2 power 8 format, there is no carries in terms of Galileo fields. So because of not having any carries, so your 9 will be so distributed like this, so 3 plus 6, which will be called as 9 here. In this way, it has been taken into consideration. So finally, GF9 value will be, RC10 value will be seems like this. RC10 will be taken into consideration, and it could be so exclusive OR with this particular first V1, and it could be generated in terms of 32 bits here. In this way, it would be taken into consideration, and how the round key will be generated here. Okay. So finally, what we are trying to specify here, as far as the complete point of view, what we are supposed to specify here is 128 bits are being transformed, and they can be so created sub keys right away from W0 to so W43. Out of these W0 to so W3, these cannot be used anywhere else. These cannot be used anywhere else. And where exactly how the keys will be generated, sub keys will be generated here in the sense. So W4 to W7 will be first round key. W7 to W10, 12 will be second round key, and so on and so on. So things will be gets happened here. and how these will be generated here in the sense. So these are the two formulae we need to follow. In second formula in the sense I modulus of 4 will be equal to 0. If this condition will be true, then Wi will be equal to T exclusive R of Wi minus 4 here. So this T will be calculated in such a way. This T will be calculated in such a way. So this is the way of calculation. And this is how the things are being happening in terms of AES. So finally, the conclusion for AES is if one bit will be gets flipped, So approximately 4 bytes of data will be gets affected. So therefore, it is such a strong kind of cryptographic, symmetric cryptographic algorithm, and people are using this one so nowadays also. So this is the complete class today, nothing more than that. So in terms of your well, I'll open. Yeah. Yeah, in terms of your syllabus, so we have been completed up to where it is, this one. Asymmetric key cryptography, it has been completed here. Sorry, not this one, second unit. Advanced encryption standard has been completed. And tomorrow, next class, we will get start with unit number 3. Unit number 3 is very simple, very simple. So this could be very easy to operate here. DES could be gets operated, not DES. Additional AES could be gets operated here in terms of this one. And here, so already mathematics of asymmetric key has been discussed by us in the previous classes itself. If you remember 5 function and then Eller's rule and Chinese remainder problem, if you remember those, so I will be very happy. Otherwise, I'll give a small introduction to those values and I'll move to asymmetric key cryptography. Otherwise, the public key cryptography by next class onwards. Public key cryptography is very simple when compared to symmetric key cryptography. So people are using, right now, this public key cryptography only. So if you open any browser and go for any kind of what you call certificates, okay, session certificates, all those certificates are supposed to be used. So this public key cryptography only. So we will discuss this public key cryptography by tomorrow's class onwards. This week, we will have complete class structure because last week I'm a bit busy while moving around for taking some what you call Aadhaar card and all those things. I have wandering here and there to Nasrapet and my hometown. So that is why 2 classes have been taken. Remaining 2 has not been taken with you. Okay. So this is today's class for us.